Let's evaluate the complexity, query performance, scalability, data relationships, and write/read efficiency for AWS DynamoDB using the following design patterns: adjacency list pattern, JSON object pattern, and multiple table design pattern. 1. Adjacency list pattern. Complexity. Low complexity. Designing and implementing the adjacency list pattern is relatively straightforward, making it easy to understand and manage. Query performance. Moderate query performance. Fetching all related data for a specific item is efficient. However, querying for specific relationships might require additional processing. Scalability. High scalability. This pattern scales well horizontally, especially for read-heavy workloads. DynamoDB's partitioning helps distribute data efficiently. Data relationships. Handles one-to-many relationships, suitable for scenarios where there are one-to-many relationships between entities. Write/read efficiency. Efficient for reads. Retrieving all related data for a specific item is efficient. However, updates involving multiple related items may require careful handling. 2. JSON object pattern. Complexity. Moderate complexity. Implementing the JSON object pattern requires understanding the structure of the JSON objects within DynamoDB items. Query performance. High query performance. Fetching the entire JSON object is efficient, but querying specific attributes within the JSON might be less performant. Scalability. High scalability. Scales well horizontally, and the flexibility of the JSON structure supports various data scenarios. Data relationships. Handles nested relationships, suitable for scenarios where data has nested relationships within a single item. Write/read efficiency. Efficient for reads. Fetching the entire JSON object is efficient, but updates may be less efficient if they involve modifying specific attributes within the JSON. 3. Multiple table design pattern. Complexity. Moderate to high complexity. Managing multiple tables requires careful planning and understanding of the query patterns. Query performance. High query performance. Optimized for specific query patterns, resulting in efficient reads. Joins are replaced by efficient queries on separate tables. Scalability. High scalability. Each table can scale independently based on its workload, allowing for fine-grained scalability. Data relationships. Optimized for many-to-many relationships, suitable for scenarios with complex relationships where many-to-many relationships are common. Write/read efficiency. Efficient for reads, optimized for specific query patterns. Writes might involve updating multiple tables, but are efficient for their intended purpose. Summary. Use cases. Adjacency list. One-to-many relationships. JSON object. Nested relationships within a single item. Multiple table design. Many-to-many relationships or scenarios requiring specific query optimizations. Trade-offs. Adjacency list. Simplicity with some limitations on specific queries. JSON object. Flexibility but may require careful handling for specific query scenarios. Multiple table design. Optimized for specific queries but involves managing multiple tables.